Wrong. Can you see? Okay, yeah, you can see my slides, correct?
Yes.
And I guess so. The topic of the talk today is really bad abstractions, right? And what should you do and not do when you build a platform and you think about what you want to abstract away and not? And the talk essentially has two main parts. I mean, first I'll say a few words about who I am and why I'm here talking, but then the talk has two parts. The first part is really what everyone gets wrong about complexity. And I'm going to take a contrarian opinion here, but one that I feel very strongly, and I think you will feel this way by the end of the talk as well. And I will show you why the goal of a platform should never be to remove complexity, because that's not a good goal for your platform to have. And it's probably not an achievable goal either. And we'll talk all about complexity in that first half and what you actually want to do with complexity and why, again, removing it is a complete fundamental misunderstanding. In the second part of the talk, we're going to make that more practical. So I'll give you 5 rules that you can use. And like when you go out and you build a platform, you're thinking and making specific architectural decisions. 5 rules that are useful to think about what is a good abstraction, what's a bad abstraction, and what will make your platform successful, and what decisions will potentially harm the adoption of the platform long term and make it hard for developers to use that platform and build upon it. Now, a little bit about me first. So I have the privilege of being a platform engineering ambassador and love this community. Have given a few talks now. I'm also the CEO of Robusta Dev. So we build HomesGPT, an AI agent for platform teams that would like to increase developer self-service. So we work with a ton of platform teams. And we see a lot of platforms that people build. So that's where the concept for this talk came from. I'm looking at all the platform teams we work with and really thinking, okay, what works really well for companies and what are some of the patterns that we see that sometimes look good up front, but don't really pan out long term, me. And we think are anti-patterns, or I think are anti-patterns. I'm an engineer by background, was a developer, ran on Kubernetes for many years. I did a whole bunch of other things in my career, but I'll try and take in this talk, I'm going to try and on the one hand speak a little bit high level about strategy and like how you should think about it. On the other hand, I'm going to also try and like translate into real specific engineering terms, Kubernetes, customize, Helm, whatever, and to make that practical so that at the end of the talk, you actually have like rules that you can look at when you're making specific architectural decisions. Okay, so let's get started with the wrong question. Everyone says, is Kubernetes too complex and should we build a platform to abstract Kubernetes away from developers? And that's actually the wrong question to ask. There's a fundamental misunderstanding here when you ask this question. And the reason why is complexity doesn't come from Kubernetes. Complexity comes from your requirements. So if your requirement is we have Java applications, we deploy those applications to Kubernetes. So we deploy those applications to production. Sorry, forget Kubernetes. And we do releases on a weekly basis of all these applications. And we want to reduce the risk that we're going to roll out a bad version. So we do canary releases or blue-green deployments. And our app is mission critical to our business. So it needs high availability. I need to have my app running in multiple availability zones and with multiple replicas. And I need load balancing. Those are your requirements. It doesn't matter whether you have Kubernetes or if you build some other platform on top. If these are your requirements, this will be the level of complexity that you have. And it makes zero difference if you take Kubernetes or you take some other platform. The complexity comes from your requirements. And I will say that many, many times throughout this talk. And the complexity doesn't come from your platform. It, again, comes from your business requirements. So if the complexity comes from your business requirements, right? Why build a platform at all? Like, why bother? What I'm essentially saying is you have a certain level of complexity. Nothing you ever do will change that other than changing your business requirements. So why build a platform? Well, the whole point of building a platform is that you control how complexity is discovered. You control the learning curve on complexity. And I'll give you an illustration of that in another 10 seconds to make that more clear. 2, when you build a platform, you know trade-offs. So maybe there are things that in general, like there's a level of complexity in general in the world when you're dealing with problems, but by applying a specific common case in your company, you can simplify the starting point. I will argue you can't simplify the complexity. You can only simplify the starting point. And 3, sometimes people build platforms for reasons that have nothing to do with reducing complexity. They just want standardization and to make things more secure and to apply certain baselines across the organization, maybe for regulatory purposes. That's another reason to build a platform that has nothing to do with complexity. So let me go back to this first point. By building a platform, you control the discovery of complexity. And I want to show you a diagram that really explains this. So what we're looking at here is two different platforms. And we're looking at the complexity of each one over time as your requirements grow. And the first platform here is what we're calling a bad platform. So the platform is really simple at the beginning, right? There's a certain level of complexity. We'll call that the period of artificial simplicity. And then you get to some use case. As time goes on, your requirements grow. Now you have some use case that the platform doesn't really support or that doesn't match this level of simplicity. So now suddenly the complexity bumps up to all these other things. Maybe you ditch the platform entirely. Maybe you have to hack in weird ways. And the required complexity, again, is required by your use case, right? If you need canary deployments, you get a certain complexity. If you need to have high availability across multiple availability zones, and you need to be able to suffer a single zone going down without impacting your users and still be highly available, then that's your use case. The complexity for your use case is constant. So what is a good platform? All a good platform does is it takes you on a better journey, takes you on this curve of going from gradual, where you get gradual exposure to complexity. So on day one, you have simpler requirements, right? You have little complexity. On day two, right? Like you have a more complex requirements, so the complexity goes up. But it just takes you on a better journey. So all you can do with the platform, I will argue in this entire talk, and I will say this again, I will show you proof of this, and I will hammer this point in again and again. But all you can do in the platform is you can control the learning curve. And where people end up and where people are on that platform, that's just a static level that is determined by their requirements. So a good platform versus a bad platform will impact that learning curve. It will impact the experience at the beginning. It will impact like whether a platform is able to really support you as your requirements grow more complex. But it is absolutely not about reducing complexity because the complexity comes from your use case. So that's the journey that we all go on. And I've seen this also many times as an engineer myself. So I worked at companies and in organizations where we had we thought at the beginning we didn't have a lot of complexity. So we thought at the beginning we have a simple app and like gets HTTP traffic. And in the end, it turned out that we had a lot of complexity and you had to do load balancing and all sorts of complicated logic. And the solution ended up being a 2009 Perl script that was impossible to maintain. But the complexity there like was, okay, you have an app, like our requirements require us to do load balancing and failover and all these other things. And it like we would have been better off taking a platform like Kubernetes that supported that level of complexity, right? And supported those requirements rather than trying to build something in-house or doing something else that didn't support that at the beginning. But eventually we had to support that level of complexity. So we added on all those things to the platform. The only difference between what we did and like what was built into Kubernetes is that ours was poorly documented, right? So, but we'll explain that more and more as we go into the second half of this talk. So before I go on, this is maybe a good point to stop as well if there are any questions or Q&A. Okay, so let's move on. Now, I want to speak about what are bad learning curves here, right? So one bad learning curve, which we all know, and that's why we want to build platforms, is you say, okay, to get started, devs, like in our company, we didn't build a platform. There's no platform. To get started, devs need to learn Kubernetes and Terraform and Vault and Helm and all the other technology we use in our organization. And to just write a single line of code and get that single line of code into production, devs have to go off and they have to do all those things and they have to learn all those things. They have to maybe read a bunch of tutorials, and only then are they able to ship their first line of code to production. So that's a bad learning curve because it's just a straight line all the way up here, right? The complexity from day one, even if you don't have those requirements, is really, really complicated. Here's on the other side of the spectrum, another bad learning curve is you say, okay, to use the platform, devs don't need to learn anything. Well, no way. I'm not buying it, right? Like it's just not realistic because, again, the complexity comes from the use case, right? So there will always be some complexity. And to use your platform, that's will always have to learn something. So that also isn't like a good pattern. And then the third one is you would say our platform simplifies all use cases. Well, you simplify all use cases. Again, it's not so realistic. And those use cases change over time. So you can't simplify everything because the complexity doesn't come from your platform. It comes from the use cases. So that's also not a realistic learning curve. So I'm going to go on now to kind of the 5 rules. And I want to take that kind of principle around complexity and I want to try and start to translate that into really specific like things that you can think in your head and questions that you can ask when you're building abstractions or when you're making architectural decisions. So the first is don't change the nouns. And I'll explain exactly what I mean by that. The second is improve workflows, not abstractions. And what I mean by that is it's very rare to be able to go and to take an abstraction and come up with a completely different abstraction, better abstraction, replace some other abstraction. What's really easy to do though is to improve the workflow that people use and how they get up and running and so on. And I'll give concrete examples of that. 3, complexity can never be eliminated. You can only reassign it. So it's like the first law of thermodynamics. You can't create or destroy energy. You can only move it from one form to another. So too, complexity can be moved around between different teams. And I'll show you what are some good ways of moving complexity around. And you can't get rid of complexity though. 4, when people extend your platform, and people will extend your platform. I mean, your platform will have to be extensible. Either you're going to extend it for people because they opened the Jira ticket for you, or you will give other people escape hashes and ways to extend your platform on your own. And we'll talk about that more. And finally, I will argue that there's sometimes a misconception in platforms that we want to simplify things or dumb them down. And that too is the complete opposite of what you should be doing. What you should be doing is you should be surfacing up the data, making the data more accessible to people, and not trying to make it so that people don't need to see the data, because that often is destined to fail. So let's go through these one at a time. So first rule, don't change the nouns. So I'll start with a bad example, right? Of what you shouldn't do. You might say, okay, Kubernetes deployments are really complex, so we're going to have some application instance file that all the developers define. In this application instance file, like you're going to put in some node binding requirements instead of node selectors because that's simpler, and you're going to put in a number of instances instead of replicas. The reason this is a bad pattern is because at the end of the day, like if devs really have like a certain set of requirements, like again, the complexity on that is constant. I can't say that enough times. The complexity on that is constant. And when devs have those more complex requirements, eventually they will have more complex requirements, and like you're not going to end up being able to simplify. But what will happen is like when people have to troubleshoot your platform, they need to learn more. Then if you changed all the nouns and now instead of having like just a plain old Kubernetes deployment, we'll see how you can make that easier still for people and why you still should build a platform. But if you have a Kubernetes deployment and someone has a problem with that and they don't know like what is replicas or what are the supported values for imageable backoff, they go up and they look it up online, they find a ton of documentation, they ask ChatGPT and they get a good answer, an AI assistant, right? And they can get help without coming to you, whereas the burden of needing to document all these things and do a fantastic job, and they still can't look it up online, will be a lot harder if you're changing the domain vocabulary. So unless you have a really, really good reason, it is almost always a good idea to keep the domain vocabulary the same. So if you're building a platform on top of Kubernetes, keep calling things deployments and pods and services. Stick to the domain vocabulary. On the next slide, I'll show you how you can still go and improve things and why you should make things or easier to get started for developers, right? Not simpler, but how you can make things easier to get started. But don't change the domain vocabulary, because if you change the domain vocabulary, everyone is just learning something that will eventually be as complex anyway, but it's poorly documented and they can't Google it. So what should you do, right? We're saying, okay, I'm saying don't change the nouns, like don't invent these completely different abstractions. What should you do? Like, what is the role of a platform then? Well, again, the role of a platform is not to get rid of complexity. The role of a platform is to change the learning curve. So how do you do that? Well, you make the getting started workflow easier. For example, let's say in your company, you're working with a lot of application teams, and these application teams know Docker. They know how to build Docker images. They have Docker files. They're building Docker images today, but they don't know Kubernetes. Well, you should have a guide and ideally a workflow that says, okay, you have a Docker image that you know how to do, right? You have that all set up. here's how you can get that Docker image onto our platform and up and running. Take your Docker image and follow these 2 steps, put in this one place, fill in this field that says image, right? Put in this other place, and it'll all just work. So getting started is easier. We haven't changed the nouns. We've just made the on-ramp a lot easier. Again, we're changing that learning curve. We're not changing the complexity. We're just changing the learning curve to it. What does that look like in practice? Well, you might say like, okay, put next, like you have a GitHub repo that has your application inside of it. And next to that application, put this customization.yaml file. And you just need to put in this one field. Put in there the image field. We've set up all the other defaults. We've set everything up. All you do is you give us this one Docker image. To get started, we'll set up everything else. We'll give you like a good default number of replicas. We'll give you all the default things that you need in order to get up and running on Kubernetes. We'll set up requests and limits and all the other stuff that you need so that you can get up and running with your application. All you did was you gave me a Docker image. I haven't changed the abstractions. I'm just not forcing you to know all the abstractions that Kubernetes provides from day one. And if you're not building on Kubernetes and you're building on top of EC2 or you're building on top of some other technology, this all applies. I only take Kubernetes in this talk as an example. And I'll say Kubernetes many times, but this is however you are building a platform. You're building a platform on top of some other technology and some other layer of abstraction. So don't change those abstractions. Just make the workflows for using them a lot easier. Get started. Here's how you get started, right? How do you do that? So you remove the day zero choices by setting really strong defaults that fit your company. So when I get up and running and I do a Kubernetes manifest and a deployment and a service and all these other things, I have a ton of choices to make up front. You can put in default choices so that now the choices that people have to make are really, really simplified. So for example, let's say you know the application stack in your company, you know that everyone is deploying, or you have dozens of business teams, application teams that are deploying Java Spring Boot applications. Well, you can take advantage of that knowledge of defaults to set up like a really good base where people just plug in the Docker image. You can automatically set up the observability because you know it's Spring Boot, so you know how to scrape the metrics on that. You can set up auto scaling according to some pattern that makes sense for your company. You can set up exactly which nodes it should run on. You can take care of all of that and give people a really good on-ramp, again, without changing any of the abstractions, just changing that learning curve. And finally, I just want to say like 2 things on abstractions in general. Abstractions are almost always there for a reason. So when you go and you remove an abstraction, then it often bites you later down the road. And I've seen many platform teams do this, where they say, okay, like we have our application developers are running, let's say again on Kubernetes, but Kubernetes is just an example, and they don't need to worry about node selectors or like how you run stuff on different pods, and they don't need to worry about like all this other stuff. We're going to simplify it away. We're going to get rid of that abstraction. We're going to do a new abstraction that doesn't have any of those options. But those abstractions are all there for a reason. What's going to happen a year from now is people will have some use case. That is the reason those abstractions were added to Kubernetes. Again, the use case, the requirements are what dictate the complexity. People have a use case that really requires those abstractions. That's why they were added to Kubernetes to begin with. And now you will have to reinvent them, right? So over time, either you just reflect the Kubernetes API and you let people, again, assuming you're building on top of Kubernetes, you let people pass through. You start with all these defaults, but people who want to build and take advantage of those like further abstractions and more complex features, they're able to, if their requirements require them to take advantage of it, let them. But our goal with the platform is to change that learning curve. So you can get up and running faster, but if you have those complex requirements, we'll let you plug them in. And finally, like the holy grail is that like what we're really trying to accomplish, and this is hard, but what we're really trying to accomplish with all of this is to make complex things possible without upfront learning, right? That's what we mean by changing the learning curve. So like the holy grail is, okay, in my organization, devs know Docker, they know nothing about Kubernetes, let's say. So from day one, they can like run on Kubernetes and they can deploy their applications to production without having to do any upfront learning. But again, over time, we've improved the workflow, but over time, as they add in other use cases, they will eventually have to learn more of that, and we'll enable that. Okay, so that's that's 2 out of 4, right? So number 1, don't change the nouns. What should you do instead? Simplify the workflows, right? So we're not changing the abstractions. We're not abstracting things away. Why I'm recommending and highly recommending, like from my experience working with different platform teams, is that you really think about complexity as constant and based on use cases. And how do you get people to to get there faster and to have an easier learning curve? Okay, now I'm gonna go back to complexity, and I want to like speak about how you really do handle complexity. And this is that complexity can be shifted between teams. So if the first law of thermodynamics is that energy is never created or destroyed, the first law of software engineering should be that you can never get rid of complexity. You can only shift it around between different people. And that sounds pessimistic, just like the first law of thermodynamics might, but that actually is really encouraging and good. So and to explain this, I want to say, like, let's say you say a sentence like, with our platforms, devs will not need to blank anymore. And what is blank? With our platform, devs will not need to troubleshoot in production anymore. Devs will not need to look at metrics anymore. Or devs will not need to worry about Kubernetes manifests anymore. Well, the question should be, why not? Right? Like, what are the requirements that looking at that enables? So if you look at it, like you say, okay, with our platform, Kubernetes developers won't need to define Kubernetes deployment manifests anymore. Okay, why not? Well, what that supports is that supports setting a number of replicas, right? That supports binding to different nodes with node selectors. That supports a whole bunch of other things. So, okay, some of those requirements might not be there today, but your requirements will change over time. So when you say, with our platform, devs won't need to do this anymore, what you're essentially saying is, with our platform, devs will never need to do the things that like this Kubernetes deployment, YAML or whatever supports. And then the question is, okay, well, like, again, why not? Is it because that requirement really isn't there? Or is it because you as a platform team will do that for them? Well, now you need to build all those things into the platform, where it would have just been easier to like to take that from Kubernetes or the deployment manifest, right? So or if you say, with our platform, devs won't need to troubleshoot and look at production anymore. Well, like, but why not? Like, someone's got to do that, right? The world didn't change. Like, someone's still going to have to do that. Or if you say, with our platform, developers, I'll give you a good example, right? With our platform, developers won't need to worry about nodes anymore. Okay, that's actually a really good example. The requirement to like care about Kubernetes nodes or have them up and running didn't disappear. It's just the responsibility of the platform team, right? So that's actually a really good way you're shifting responsibility around. You're shifting complexity around. So you're saying, okay, we're going to design an interface. The devs aren't competent at running Kubernetes nodes, or if we're running on-premise Kubernetes, at running the master nodes and the control plane and so on. Okay, they're not competent at that, and they don't need to know that. So the requirement to run these hasn't disappeared. We're just shifting that responsibility to our team. So you can take complexity and you can assign that complexity to different teams based on what each team is competent in. So, for example, maybe a good example of this is like, devs won't need to worry about observability anymore, right? Or won't need to worry about scraping their Prometheus metrics. Okay, well, who is going to be responsible for that? So you can say, okay, I have the devs will expose metrics, right? That's something they're competent at. They do that in code. They know how to do that. Now, we have a separate team that maintains the observability stack, and that team will automatically scrape these according to these patterns or whatever. Okay, that's great. So you can, again, move things around in terms of who's responsible for it, and you should do that. And then you can design interfaces for who does what in your platform according to which team is competent in different tasks. But you can never make the tasks go away. You can just shift it to other people. And I want to show an example to prove this, right? So I want to show an example of like Docker versus virtual machines. And I went on to Google and I just searched like benefits of Docker versus virtual machines or something. And this was the first result that I found. And I'm not going to go through the whole thing. I'll just take one point here as an example. So according to the first result on Google, like, one of the benefits of Docker versus virtual machines is reduced and simplified security updates. Now, that's the biggest lie in the world, right? Anyone who deals with Docker and anyone who deals with Kubernetes and rolls out images knows that keeping those images up to date with security vulnerabilities and patches and rebuilding the images all the time, that is the biggest headache in the world. Yet, Docker and Kubernetes are actually much better at that and easier to maintain it with than virtual machines. So, like, Docker and Kubernetes are actually way better at handling security updates than virtual machines. But it's not because the need to do security updates suddenly changed. Rather, we were able to split up that complexity between different teams in a way that made more sense. What I mean by that is that when you look at doing security updates, there are actually two types of security updates. There are security updates on the nodes and the infrastructure, right? And the operating system. And then there's security updates on the application or the third-party libraries that my application depends on, right? So what we've been able to do with Docker and Kubernetes, and Docker and Kubernetes are better at managing this than virtual machines, we've split up the complexity. We've reassigned that complexity to different teams. So we said we're going to assign the complexity of keeping the nodes up to date and all that, and that's a big headache, and the operating system patches to whatever team is running those nodes and maintaining the nodes in the control plane. And maybe we've even shifted that complexity to Google or to a hosted Kubernetes provider, which is even better because now we've shifted outside of our company. And we're going to shift to the developers now, and just to the developers, the responsibility for updating their applications and updating the third-party libraries that they're responsible for. But the requirements here and the real world complexity of this has not changed. The requirements are, and like the facts of life are, that you're building applications that depend on third-party libraries, and those libraries very often will have vulnerabilities, and you have to update your apps often, and the operating system that you use will have vulnerabilities, and you'll have to update that. But we've been able with Docker and virtual machines and like with a better platform to reassign those responsibilities in a way that makes it a lot easier for a company to do it. So to go back to the third principle here, we can shift complexity around to different people. That's a really good thing because it means that we can put complexity on the person who is competent in handling that complexity. And an infrastructure, an IT team, or DevOps team will be competent at updating the nodes. An application team will be competent at updating the software packages that they use and they know how to test that. But we can never get rid of the requirement or the complexity to keep stuff up to date with software updates and security updates. Okay, so fourth principle. Oops. Extend with escape hatches, not Jira tickets. So here's the litmus test for deciding if you built a platform or not, and a real platform. A platform is somewhere where most of the value comes from people building on top, where most of the value comes from people doing things that you did not expect. So the question you should be asking yourself is, when you're asking, did we really build a platform, is can people do things with our platform that we did not expect and we did not design it for? That's the definition of a platform. An operating system is a platform, right? People do things with operating systems. Whoever wrote the operating system certainly does not anticipate. I would argue that now AI is a platform, right? And large language models are a platform. People do all sorts of things with that OpenAI did not imagine initially. A platform is somewhere where people can do things with that you did not expect and you did not anticipate. So if we take it as a fact of nature, and we should take it as a fact of nature, and just a hard fact that we can't change, that that requirements are going to change over time. So whatever we design for today, it will change over time. And if we really were successful in building a good platform, then people are going to be able to do things with our platform that we didn't anticipate. And that's a wonderful thing because their requirements will change in ways that we could never expect. So when their requirements change, and they will change, we can't control whether the requirements change or not. But we have a decision to make. When the requirements change, do they need to open a Jira ticket for us, for the platform team, and we need to add some new capability to the platform? Or do we give them enough escape hatches that they can extend the platform and they can do something that we didn't anticipate to meet their new requirements? And I'm going to go back to the example I gave earlier. Like imagine that you've created some new abstraction layer on top of Kubernetes and you're abstracting away the Kubernetes and like everyone can only work with some very strict subset that you define. Well, that's not a platform because people can't extend it. They can't do things you didn't imagine. But if you gave them, for example, a great Helm chart with a whole bunch of defaults, and all they have to do to get up and running is to like give you an image file, right? They just give you the Docker image, and then you're up and running. And on day one, they have to do nothing. But when they have more complex requirements, they can plug in any arbitrary YAML, or they can plug in certain types of arbitrary YAML that the security allows for, right? Now you built a platform. People can do things that you didn't anticipate. They're able to extend it. And again, we've succeeded in building a platform because we've shifted the learning curve. We made easier things possible on day one. So the goal here is to make it possible for people to extend our platform, to do it in ways that we didn't anticipate and we didn't think of, and to let them do so with escape hatches so they can do that on their own without coming to us, without opening a Jira ticket. And at the same time that we're doing all that, making the platform extensible, we don't want to make the experience on day one more complex. So we don't want to force people up front to learn all these extra things. The whole point of our platform, again, is to shift that learning curve. We want people to start on day one, have to know this, but be able to learn more over time. So a good platform makes the common things really easy, but it makes the complex things possible. And it gives people that option to extend the platform in ways that we didn't think of. So when you're designing platforms, you should ask yourself, when the requirements change for the developer teams, and they need to come along and they need to do something that we didn't plan to support. For example, they need to do canary deployments. For example, they need to run AI workloads, and now they need to put in node selectors because they need to run on GPU instances. And we never thought of that, right? They need to do all sorts of things with the platform that we did not anticipate. When they need to do those things, can they do them without us or not? And if they will be dependent on us and they will have to open Jira tickets and we will have to go off and support it, you will never be able to support that at scale. And you will always be chasing your tail and always chasing the requirements. You will be slowing the developers down instead of helping the developers go faster. So a good platform lets everyone go faster. It doesn't put in these arbitrary limits that stop people from moving without you. Now, a good diagram that really illustrates this is from a project called CubeVAA. And I just love this diagram. And it kind of shows the evolution of platforms over time. And the point is, here you have on the left-hand side, you have all these unlimited capabilities of Kubernetes ecosystem. So people can bring a service mesh, right? They can use Istio, and they can have Kata for auto scaling according to, I don't know, Kafka topics, right? And Prometheus for observability. And there are all these other great capabilities in the Kubernetes ecosystem that your requirements, like you might require that complexity because those are your requirements. And then people go and they build a platform as a service that is really simple and restrictive. And it creates this bottleneck. And user requirements grow over time, but this becomes the bottleneck. That doesn't grow. So that doesn't let all the user requirements through. And then that creates a burden on your platform team that always needs to go off and chase and like add on new functionality. And you can never keep up with it. And you're anyway just reinventing stuff in Kubernetes or in EC2 or wherever you're building on top of. So build escape hatches into your platform and make sure that people can do things in your platform that you did not anticipate when their requirements inevitably change. Now, I want to go on to the last principle, and that's don't hide the data. Surface data up. And there's sometimes this misunderstanding that we want to simplify things. We want to dumb them down for developers. And I say absolutely not. It's a fundamental misunderstanding. You don't want to simplify things. Again, we can't change the complexity. How can we simplify? That's the requirements. The requirements determine how simple they are. What we can do is we can only change that learning curve. And the reason this is so important is because whether developers can succeed at self-service, whether developers can really use our platform and succeed in self-service and use it on their own, or whether our team will eventually become a customer support team that just chases after supporting the developers every single day, right? Whether developers are successful with self-service, whether they depend on us for support, is determined by the unhappy path. What happens when things don't work well? A developer deployed an application and it's failing for some reason and it's not working. Can they troubleshoot that on their own, or are they dependent on us to troubleshoot that and they have to open a ticket for us? And the goal of the platform is to make it faster to troubleshoot common errors, not because we're removing certain complexity or we're simplifying, but because we're improving the workflow on that. We're servicing up relevant data. So we're making it easier to do what they already have to go and do. So as an example of that is like maybe in your platform or in the apps that application developers are running in your organization, you have a microservices architecture, and it's really common for things to fail due to failing upstream services. And that's a really annoying, hard problem to troubleshoot, right? So you can make it easier for people or make it faster for people to troubleshoot those common types of errors, for example, by adding tracing into the platform, making it really easy to get up and running. And you're not simplifying things or dumbing it down. You're just giving a really easy on-ramp to get some of these capabilities and to learn more over time incrementally. Now, before you go, if you're set on ignoring this and you say, okay, I'm going to simplify things, I'm going to dumb them down, and you're going to ignore the advice I'm giving you here, at least do one thing. Before you simplify, diagnose the real root cause. And what I mean by that is, let's say today, devs are not succeeding on running apps on Kubernetes, and they come to your team always to go and troubleshoot stuff. And you say, okay, we're going to build some other abstraction there. We're going to simplify and dumb it down. Well, like, what is the real problem? Is it that today they lack access to troubleshooting data? They can't see the pod logs easily. Is it they don't know where to look? Because these are all problems that we can solve, right? We can make it easier for them to find them. We're not simplifying it, we're not dumbing it down. We're just taking the workflow of like my app crashed, I got a notification, I want to find the logs. We're making the workflows easier. We're not changing the abstractions. So like find out why is it really hard today? Is it a lack of knowledge? Is it a lack of expertise? Is it that they just don't have access because they're restricted and they can't actually like view the logs, right? So figure out what that is, and then figure out how you change the learning curve on that. And very likely the goal again is not to remove complexity. Like if you have trace data and devs don't know trace data, I mean, like you're gonna need to get the devs to understand how to use trace data and how to look at that, right? You can't like that's not something you can really fix if you have a microservices architecture and cascading failures. Like that's the inherent complexity. That's not going to change. All we can do is we can help devs with that learning curve. Now, I'll give one real world example. And so we work with a company that has like a ton of tracing data. And they had a problem was that they had these cascading failures and devs one never remembered to look at the tracing data. So they had cascading failures, and the IT and infrastructure team and platform team would get called in and they'd troubleshoot things, and it would always turn out it was an application issue, not even a Kubernetes issue. So they rolled it back to the application developers and tried to prove to them that it was actually an application issue, and they needed to go and fix it. And devs never looked at the tracing data where they could have seen a lot of this on their own. And even when devs did go and look at the tracing data, only staff engineers were able to like really go and interpret that effectively. So they rolled out an AI agent that like surfaced up the relevant data when devs were looking at the others. They were in context and they like made it easier for them to see the relevant data. Oh, here's some tracing data. Here's where you should look. Here's how you can solve the problems with that. And then the devs started succeeding. Well, we didn't simplify things. We just changed the learning curve. We made data more accessible. We didn't hide the data. We surfaced up the data. And then the burden to support those developers went down. So that's like an example of the type of thinking that you should do. Think, how do I surface up data? How do I make the workflow easier for people? How do I help them find the right data faster? Not how do I hide the data or how do I simplify it? Because you can't, like to troubleshoot some of these issues, there's the data you need to look at. Like you can't simplify. If you hide it, you make things harder, not easier. So to kind of wrap this up, I just want to go back to this learning curve again. And this is the last slide. So this is just a summary of really everything that we've spoken about. You can never remove complexity, or you can very, very rarely remove complexity, right? And the goal of a platform should not be to remove complexity, because it's the complexity comes from the requirements. You need canary deployments. You have a certain level of complexity. You need auto scaling according to Kafka topics. You need a certain level of complexity. You need observability data to troubleshoot, or you need profiling data to troubleshoot issues inside the application because you've had a bunch of errors like that, right? You need a certain level of complexity. So complexity is a constant. All we can do with a platform is we can change the learning curve and we can expose people to that complexity gradually, and we can make it easier on day one while still allowing them to learn more over time. And a bad platform tries to artificially reduce this, and it never really works well in the real world because eventually like the requirements go up here. Bad platform might put you all the way up here at the top at the beginning, right? So you're hit with all this complexity from day one when you don't actually need any of that. So all we can do is we can change the learning curve. And if I want to rephrase that, it's not that all we can do is we can change the learning curve. We can have a huge difference just by changing the learning curve, right? We work with tons of companies and they build great platforms. And we've seen companies that have done such a great job at this. And companies where devs, for the most part, do not need to worry about certain aspects that the platform takes care of. But it's not because they're hiding them. It's because they're exposing them to them gradually. And when devs start off with those lower requirements, then they don't need to worry about them. And over time, if they grow to them, then they are able to worry about those requirements and take them on. So those are my 5 tips for building platforms. And this is a bit of a contrarian take, I know. And we've seen it, though, play out many times. And I've seen it as an engineer as well, where I've been at companies that just went and reinvented things, and we ended up reinventing something really complex that was just as complex as the thing we were trying to abstract away because we didn't understand that the complexity came from our requirements. So I hope this is really useful to all of you as you go out there and you build platforms, and you can take some of these rules of thumb and think about them when you make specific architectural decisions. And I guess we'll stop here for questions. That's it.
Thank you, Natan. Yes, everyone, this is your chance to ask the questions. So pop them into the webinar chat or the Q&A box. But we already have a few, so I'll read them out for you guys. What if your abstraction is over different underlying technology and then the terminology used is different?
So there are rare cases where this is justified. There are a lot of cases where people think this is the case, and they think we're going to change the whole language and the whole nouns and like the complete terminology, and they end up not realizing why some of that terminology, some of that complexity was there to begin with. But there are cases where this is true. So I'll give you an example, Manish. So the best example of this is like a compiler. People used to write assembly language and machine code, and then along came compilers. They said, okay, no, you're going to write C, and it's a whole different terminology, a whole different set of nouns. So there are cases where it really makes sense. You can make things like easier for the simple case, or easier for even most cases, right? By changing the requirements and by giving a different set of abstractions. But when that was done, if you look at the cases of compilers, compilers still give you an escape hatch. Compilers still let people, even to this day, like drop down and put in block of assembly if they need. When you're using Java or you're using C Sharp, you can still drop down. You have an escape hatch to call native code, for example. So you still have those escape hatches. And of course, there's a trade-off that's being made, which is that you're losing the ability to like fine-tune the performance and so on. And a lot of the complexity has shifted to the compiler writer, of course, right? So there are cases where you change the vocabulary. And I'd say there's probably about once in a decade like shift in the industry where the vocabulary really changes. So it does happen. But if you're building something like that in-house, just to build an internal developer platform, I would be cautious around that because often in those scenarios it's not justified. But there are cases where it definitely makes sense and it happens. Just be very careful if you're changing the vocabulary. Now I see another question. Yes, go ahead.
Yes, so well, I guess this is a more of a general one, but Alexandra is asking why is it usually Kubernetes? Multiple workload types should not be deployed in a container environment, and moving it to Kubernetes just because I have a system built from scratch to act as a platform is sometimes a really bad idea.
So Alexander is right, first of all. I mean, he's right that, and again, you go back to the like if you take one thing away from this talk, it's that you should think about the requirements first, right? And that the complexity and what you need from the platform comes from the requirements. So he's absolutely correct on that. And not everything should fit on Kubernetes. And like there are types of apps that you can just run an app engine or simpler environments. There are types of apps that have all sorts of stateful needs and they don't belong on Kubernetes. Um, but I'll answer now the first part of the question, which is why is all the content around platform engineering always around Kubernetes? Well, it's just the most popular. Like I don't know, I've met in now I think 3 years, almost 4 years at Robusta. Um, we met a lot of companies and like a lot of customers, and I think we turned away a company once that was really interested in what we did, but they ran on Nomad and it wasn't a fit for us. Like every other enterprise company we meet always runs on Kubernetes or is migrating to Kubernetes, maybe on virtual machines today or something else. But they're in the path of Cloud Foundry, but they're in that migration. So we just talk about it a lot. I talk about it a lot because it's the most popular thing, and so where a lot of my customers are. So speaking about that tends to have an impact on a larger number of people than speaking about other technologies. But you are right. I mean, don't throw Kubernetes at something where the requirements and like the type of complexity is not a Kubernetes shaped problem.
Okay, next one. What key metrics do you think are important for determining whether a company is on the right track?
I'm going to say something unpopular. Don't look at metrics. Speak to speak to three people, three developers from different engineering teams, and ask them like what they love or they hate about your platform. I know this is hard because we always want to make it like data driven, and we always want to look at the metrics and look at the numbers. And it's if you have to look at metrics, right? Look at the adoption, look at whether people are actually using your platform, they're using other things, and look at those. But don't uh, for the most part, you will get better insights by grabbing three developers who like are using your platform saying, tell me what you love, tell me what you hate, you will learn more from that than the metrics. Because the metrics can say you're on the right track or you're on the wrong track, something is working, something isn't working, but you don't know what until you grab the people and you speak to them. When you grab the people and you speak to them, just based on the feeling, you often get a sense of whether you're on the right track or not. So it's hard because we want to look at numbers, and sometimes um, it's easier to look at numbers than it is to like grab people and do a really good session and like grab them for coffee and sit down and like go and speak to them and get something time in their schedule. But if you just speak to three people, it's a rule I think in product as well, and for startup founders, right? Like you want to have all the data. But at the beginning, when we started out, we didn't have all these customers. Now it's easier. We could look at metrics, right? When we started out, started building an AI agent and we started building what we do. Like we didn't know if we were on the right path. We had looked at metrics in the very early days of Robusta, like I don't know, like half the metrics are zero all the time. Like, how do you know if you're going anywhere? Like, it doesn't help you. But if you speak to the people and you hear from them, you say, oh, yeah, I love this. This solved this problem in my company. Oh, but that didn't work. I couldn't install because your security requirements weren't good. We need an on-premise large language model. Oh, okay, we can do that. You end up learning a lot more from just grabbing three people and speaking to them. And of course, as your platform grows, as you adapt, of course, you eventually look at metrics as that matures. Today we look at metrics as like it's easy, right? I check metrics every morning. But as you grow, as you start, I recommend just speaking to three people. That's all you need to do.
Okay. Tan is asking, how do you balance building escape hatches in your platform while ensuring security?
So it's a great question because what Tan is saying is these two things are fundamentally opposed. You build escape hatches and you let people do all these things with your platform. You build a great platform, and on the other hand, you maintain security, right? So I want to just be even more clear about this. Like we have two conflicting goals when we build a platform. One, we want a great developer experience. Two, we want a secure and and cost-effective platform. And those two things are always to some degree at odds with one another. Like what's the best platform in the world? No problems for everyone. Like, I don't know, a developer comes along and you spin up a giant mega cluster with 1,000 Kubernetes nodes, and like they put their application on there, and they don't need to worry about anything, and like and that, you don't even need to worry about auto scaling on the nodes or anything because like they have so much room and it's like this massive thing. Of course, it's not very performant or cost effective. And you say don't worry about security, and they can do whatever they want. And like, of course, that's the easiest platform to use. That's the best developer experience, but of course, that's not viable either from a security perspective or a cost perspective. So they are always at odds with one another, and I think the devil here is of course in the details, but unless you have a security reason, so it comes down to the question: do you blacklist or do you whitelist? And some of this comes down to your team's maturity. If you have a team that is less proficient in Kubernetes and less experienced, then you can white this thing. So you can say up front, you're only allowed to do X, Y, and Z, or you're allowed to override these fields, but you're only allowed to like plug in values for these Kubernetes fields A, B, and C. You're not allowed to plug in something for anything we didn't allow. Now the problem here is that your platform isn't very extensible. People will go and have to open Jira tickets for you. But if you have a lot of teams you work with, like over time, you do grow that maturity and you learn really what is secure and you look into each thing and you grow your platform and you put in more escape hatches, and you learn over time. But if your company does have knowledge today and you have the expertise already, then I suggest you blacklist instead and you say, okay, here are the things we know are dangerous. We're going to disallow these, but everything else we will allow. So the answer to this and how you balance that will depend on the level of knowledge and maturity within your team.
Okay. Um, we are talking about gradual exposure of complexity. Do you mean incorporating more features over time? Isn't it abstracting away complexity? It is the value platform provides.
No. So sorry. No, I'm saying the opposite of this. I'm saying that complexity is not determined by you or your platform. Complexity is determined by your users and their requirements. So, as an example, if your users need to do canary deployments or they need to auto scale based on Kafka topics and the load inside those topics, right? Then that is a set level of complexity that your platform cannot influence. It's an external factor. The complexity is given to you. You don't get to choose it. So all you can do is you can say for people who don't have those requirements, we'll make it easier for them to start off. So I'm not saying you should add more features over time. I'm saying actually if you're building on top of something like Kubernetes or some other technology, right? Then what you should aim to do is not to simplify or to like abstract it away. What you should aim to do is to change the learning curve so that people can get started on day one with less of this. What this typically means is just setting really strong defaults, right? Or what it means is giving them a set of patterns or a set of templates they can reuse. But you're not trying to abstract it away or dumb it down because unless you are certain for 100% certainty that people in your company will never need canary deployments, they will never need auto scaling, they will never need all these other things. If you're certain that they will never need any of those, then okay, yeah, you can remove like them and you can have a platform that doesn't allow any of those. But you haven't really gained anything because people weren't going to use those features anyway. So like, who cares? All you can do is you can make it easier for people to get started and you can change that learning curve. And typically the way you do that is like with really good documentation, with templates. Templates are fantastic, right? With setting really strong defaults. Maybe you do have like a platform is like a Helm chart where you plug in some standard values and you set all these stuff up for the company. But like they just plug in one value there and that works on day one. Okay, that's great. You set a whole bunch of defaults, people can get up and running faster. You haven't abstracted it away. Okay, next question.
Okay. So Carson is asking, so having no platform at all, what would you start with? Easiest implementation, lowest hanging fruit? Do you have a good principle?
Yes, I will define, and I'm going to assume here again Kubernetes. I'm sorry to everyone here who's not on Kubernetes, but it is the majority, I'm guessing. So I'm going to assume that you have Kubernetes, and I'm going to make some assumptions here, right? Because I have to assume about your requirements. And feel free to message me afterwards on this as well. But I'm going to assume that you're running on Kubernetes, and I'm going to assume that you have a lot of enterprise developers who don't really know Kubernetes all that well, but let's say they're familiar building Docker images. And you want and they have certain requirements. There's a reason that you're moving, right? If there always is a reason for motion. Like they're obviously somewhere today and you want to get them somewhere with the platform, right? Like there's something that you're going to do, or else you wouldn't be building a platform. So there has to be some motion. So I'm assuming that you're moving like those developers to Kubernetes, or you're trying to get new teams onto Kubernetes, or you're trying to help teams succeed at it more and not shoot themselves in the foot, for example, right? So the minimum viable platform is typically either a Helm chart called like standard application, right? Helm chart or a customization by overlay where the developers put in the name of their image. And the developers put in the name of the image because they know Docker images and you know how to build that. Say, build this image, put the image here in this one file, and that's all. And then as their requirements grow over time, now they want to take on other things and you customize the auto scaling, you do all those other things. You give them like there more of those hooks, or you let them just have the escape hatches to set more and more of those things and override them themselves. But the minimum viable place is just giving them a really good template or starting place where they only have to fill in like one field to get started. That is a field they know and they're familiar with. That matches their requirements today. And then over time, though, it can, of course, grow. You're giving a template, you're giving a paid path, but they're allowed to deviate off of that.
Okay, got 2 more minutes. Mark, hey, thanks for the talk. Interesting point. I often observe that the requirements are unclear and can be simplified significantly. This is the opposite of complexity is constant. Shouldn't complexity change over time due to change in requirements?
Yeah, Mark is correct. Really, what this graph should read over here is this graph really should read the maximum complexity of your platform or the maximum complexity that each user hits is constant. It's not an entirely accurate graph in that sense. Mark is spot on. Thank you for spotting that. I'll have to update this next time I give a talk on this. You're correct though.
Okay. Faraz is asking, how do you know if a platform is actually helping or just adding more steps to the process?
Grab 3 developers and ask them.
Okay. And then last question. How do you manage feature parity when you start integrating different tools to a centralized platform, such as Backstage, where building UI elements, observability, and operations slowly becomes challenging?
Okay, I love this question. I absolutely love this question. So I'm gonna make some assumptions here again, and then I'm going to answer that, okay? But I'm going to make some assumptions, and the assumptions I'm going to make is like what's behind this question is that um, you have an organization today where there are a bunch of you're probably in a big enterprise organization, and there are a ton of different like tech in your organization, like Kubernetes and Vault and Terraform and the observability tools and logging and the separate tool and metrics and traces and like all these other things. And today it's a big pain because developers need to know about all those different things. They need to remember them. They need to look across a million different systems, and they don't even know where to go. And therefore, you're taking something like Backstage, right? And you're building a centralized platform. And like now, suddenly you have to plug in all these different UI elements to bring all those in. And that becomes really challenging. So the way I would think about it is what you are trying to do is not to abstract that away. You can't abstract it away, right? Those all those things exist for a reason. Like if you were able to abstract it away, then what you're essentially saying is like, I don't know, we use Splunk for logging, but really like what Splunk did with, I don't know, like $100 million and like a team of, I don't know, like 1,000 people. It's not 100 million, it's more, but a team of 1,000 people and engineers, we're going to do in a platform with like half a person. No, it's not realistic. Like there's real logic and complexity there and so on. So, and developers will need to use all that functionality occasionally, or at least a lot of it, right? So they're going to need to go and like to run all these complicated queries in what is it, SQL, SPQL, Splunk query language. And you can't incorporate all that into your platform. That shouldn't be your goal because your goal is not to abstract it away. Your goal is to help with the learning curve. So what you should think about doing is how do we make the platform a jumping board? How do we make the platform a place where you can have a friendlier learning curve and discover all of that, but you will never have feature parity because you cannot, like feature parity means that those other tools are doing all these things that you don't actually need. And very typically that's not the case. So you will never have feature parity, but you should think about how do, like, what is the core challenge we're solving? Is the core challenge we're solving that devs don't know to look in those other places? So, okay, like, I mean, that's part of why we build an AI assistant so we can service up for devs. Okay, you should actually go and look here. Is it that they don't have the access to look in some of those other systems? Okay, that's an access problem, right? How do you solve that? So, like when we think about this, because we encounter this on a day-to-day basis, right? We'll never, like an AI agent, we'll never have feature parity with everything else, but we don't need to. Like the core problem we're solving is that devs don't know or remember they should look at the tracing data. So we say, oh, here's a trace you should look at, and then we'll link you up to the tracing tool. So the goal is not to have feature parity in everything within your platform because that's impossible. In a centralized UI like Backstage or an AI agent or whatever you're building. The goal, though, is to solve the discoverability problem and help take developers on that journey with that learning curve to let them jump out to the other platforms. So you should never try and reach feature parity. You should just try and identify the main areas where that learning curve is hard today, or it's breaking, or people don't know things they should know or should be using, or where they require a certain level of complexity, but they don't even know where they're not there. And how do I take them on that journey? So in practical terms, how do I make Backstage a jumping board to learn more and dive into other platforms, not the only place where people ever have to go?
Okay, thank you for answering, Natan. We're going to have to wrap this up, guys. But please, if you have any questions that we didn't get to answer, um, share them in our Slack channel. Natan will be there to answer everything. Um, and yeah, thank you so much, Natan, for this great session. We all learned a lot. But yeah, guys, so please, if you have any questions, share in the Slack channel. Natan is also there. If you want to message him, he will help you out. So I hope you
I'll
all have a
jump
great,
right over there now.
yeah,
I can stay
he's
around for
already on
another
the
10
way.
minutes or so on the Slack platform. And I'm sorry, on the Slack channel. And then I'll be back afterwards as well. So I'll check that tomorrow as well. But I'll be around immediately for the next 10 minutes or so to answer questions there. And I just want to call out, Pablo, I love the term there, MV platform that you've coined. So maybe I'm going to reuse that. I love that concept of an MV platform. So thank you, everyone, and thank you for participating and asking questions. And I love it because it makes it feel I'm not just talking to a recording into Olivia. So thank you for participating, and I'll see you all on that Slack channel in another minute.
Thank you, everyone.